So it's electronics 2 test number 1. If you will look there at the bottom, it says there test 1, semester 1, 2012. I just want to point out a few things here just to make life easier for myself, which was actually explained before. I reminded you a lot of times during lecturing. Where can I zoom in? So how it works is we will discuss the test eventually, and then you get the opportunity. So I'm going to discuss the test, and you make notes during we discuss the test about things that you're not sure, you feel that I did correctly or I didn't give you marks or whatever. And after we have discussed the test, you will have the opportunity to come and see me about marks that you felt you should have gotten but you didn't get. But just to make sure that we're all on the same page, the following is very important. Okay, that's not going to work. In the first page of your test, there are instructions to candidates. It says, answer all questions, show all calculations. Some of you are just writing the formula and then you're writing the answer. Then you didn't get some marks. Don't come and ask for marks. You must show me the calculations in order for me to give you marks. All right? You are doing electronics 2, which is the second year subject already. You should know how it works by now. The next thing which I said, at least once a period, calculations accurate to 3 decimals. If you did not get marks at some stages because you didn't calculate accurately, do not come and see me. You are not going to get the mark. All right? Express all calculations in metric prefixed engineering notation. I said no 0, something. That's not engineering notation. Engineering notation has between 1 and 3 digits before the comma expressed in the correct metric notation. Do not come and see me if you lost marks with that marking. And last but not least, these are the ones that I've added to the universities. Untidy work will be penalized. I cannot read. Let me just get an example here. I'm sure I have one here. I will go and get one now. I cannot read if it looks like a fly fell into the ink and walked around the page. It's not possible for me. I'm marking 300 scripts between all the other work that I have to do in a week's time. Read neatly if you want marks. So if I encircle something and I put a question mark next to it, mostly I can't read. If you write something like this, you said, for instance, it's 0,73, whatever you decided. No, man, that's not a 0, it's 7. Can't mark it. I don't know. Is it a 0? Is it a 7? I told you before. Cancel and write again so that I can read. Okay? If you can't make up your mind about the answer, I also can't make up my mind about the marks. All right. These are things that you should know by now. You're grown-ups. All right? So, another thing that I've written down here while I was marking, I don't know how you want me to give you marks if you work out that R accent E should be 7,5 ohms, but you don't write ohms. I don't know if you meant kilo ohms, did you mean mega ohms, or what did you mean? No unit, no mark. Don't come and see me for questions like those. A question like we're going to discuss now, where you had a multi-stage amplifier. You've got two stages, but you write VB, and you write R accent E1. Is it one? Is it the first stage? Is it the second stage? How must I know? How must I know? You have to write. What are you calculating? If you don't write, I can't give you marks. Okay. And then, oh man, schoolwork, rounding off. I will also show in the test. You don't know how to round off. If you don't round off correctly, you most probably lost marks. Okay? Anyway, we're going to discuss the test now. Make notes. After we've discussed the test, you will get the opportunity to ask questions and can come and complain. You will see in the memo, I also indicated, it's actually supposed to be red, but there's something wrong with the screen. You can see there, I wrote, where did I get this question from the textbook? So you must write in your homework book or somewhere. Test number 1 for this semester, question 1.1 was that, and it's found there. Because after we've discussed the test, I'm going to take everybody's tests in. You don't keep the tests. You come and see me. You will sign next to the mark that I wrote in, or after we have agreed on what your mark should be, and you hand the test in. If I haven't got the test, I'm not going to hand in your mark to the exam office. All right? So please make notes while we are discussing the test, so that you're sure that you know what to go and revise when you study for the exam. Anyway, let's start with the test. Question 1. Let me just see if I can enlarge it again, because I don't have the option of a keyboard here. Let's do it this way. Too big. All right, that fits in. Question 1. What is the purpose of biasing? This I asked you to mark in section 6.1's introduction. The answer, to establish a Q point. If you wrote, you have to establish a Q point, you got 1 mark. The second mark was for about which variations in current and voltage can occur in response to an AC input signal. I also asked you, if you will go and look at the videos again of chapter 6, you will see that I asked you to underline this. It is important. It is actually revision of Electronics 1 work, where you discuss the various biasing circuits. So what is the purpose of biasing? It was shocking to hear, to see how few of you knew. The next question, 1.2, identify the amplifier configuration of each amplifier in the circuit diagrams below. Remember, we did this, and I said it's very important that you know which configuration of amplifier you work with. Otherwise, you're not going to know which formulas to use in your calculations. How do I identify? I go and look, where's the input, where's the output, the remaining terminal makes it the configuration. In the first figure there, figure A, I can see that the input is at the base, the output is the emitter, so it makes it a common collector amplifier, of course. But I caught most of you out with the second one. I've got weird and strange answers here. Of course, input is still at the base, output is still at the emitter, so it's still a common collector configuration amplifier, but it's using a Darlington pair. So if you didn't write, if you wrote there, if you wrote Darling common collector, I don't know what that means. or something in that vein, you didn't get your mark, of course. Ne? You should have told me that it's still a common collector amplifier, but it's using the Darlington pair. And there I wrote again, it was figure 654 on page 314 for the first one, and figure 655 on page 315. Alright, question number 2. It seems the students also don't understand instructions. I wrote there clearly, strike out the wrong words in the statements made below. Then I gave you an example. You can see there's a line through the no. So the things that's not true, that was highlighted here, you should have struck through like I've done here. One student did nothing, and then at the end he said yes, because I said here in the example yes. Alright, this was found on page 278. Because of the high input resistance and the low output resistance, a common collector amplifier can be used as a buffer to minimize loading effects when the circuit is driving a low resistance load. Of course, ne? 1 mark for each one of those. Page 278. Alright, 2.2. I said, calculate the following for the circuit in figure 1. Do not neglect the internal AC emitter resistance in your calculations. I told you repeatedly, read the question carefully. Alright? So the first one was there to determine, the first question was to determine the voltage gain when a load of 1 kilo ohm is connected to the circuit, for 2 marks. Now if you go and look at figure 1, look at the information that's been given. Some of you even went and calculated R accent E. R accent E is given. Can you see there? R accent E is 25 volts. There's the information given. Alright. Now I changed the circuit. I said, okay, take this circuit, add a load resistor. What is the voltage gain going to be? Voltage gain, because there's a load resistor, remember I have to calculate R small c, which is RC in parallel with RL, 3,3 in parallel with 1 kilo ohm. The answer to that was 767,442 ohms. Below the line, I have to go and look at the circuit. Remember we said, voltage gain always maximum. I go and look. RC over R accent E. That's the maximum voltage gain for a common emitter amplifier, which I hope you recognized. It is a common emitter amplifier. Alright, we dealt with RC. I had to calculate R lowercase c, to determine RC in parallel with RL. Below the line, what do I have? What do I have? Is there any swamping at this stage? No, of course not. I gave you R accent E, and I told you in the question, do not neglect R accent E, so it must remain. And there's no swamping, so I have to include RE1 and RE2. Right, that is actually RE2. RE1, RE2, each 120 ohms. R accent E 25 ohms, so I have below the line 265 ohms. The answer to this, 2,896. Not 2,895 or 2,897, 2,896. Then you got your 2 marks. You can see here, I gave you 1 mark there for using the correct formula, and here at the answers, you got your other mark where you had to write the answer in. Alright, B, R in at the base. R in at the base. Have to look at the circuit. Beta AC is given. R accent E was given because I told you not to neglect. No swamping, 26.5 ohms. So 1 mark there, 1 mark at the answer. 4 marks so far. And with the last one, I asked voltage gain with RE2 bypassed and no load connected. RE2 bypassed, so you should have done this. And then calculate the voltage gain. And there's no load resistor. So it remains RC, which is 3,3. I told you not to neglect R accent E. So it's 25 ohms plus 120 ohms. 22,759 was the answer. 1 mark over here for using the correct formula, and 1 mark over here for the correct answer. 6 marks all in all. Most of you fortunately had that. Oh, but my personal favorite. What happened here, ladies and gentlemen? We have discussed that so many times. So it could either be a fact of you never attended class, or you were sleeping in class. I can't think of any other excuse for not being able to do this question. I even discussed this problem, I think, the Wednesday and the Thursday before the test was written. Can you recall? So why everybody didn't get 11 marks for this question is beyond me. What is the very first thing that I have to do when I work? Can you see that these are 2 common emitter amplifiers? What's the first thing that I have to do? Always with a common emitter amplifier. Let's just discuss the first stage. Hopefully you recognize just the first stage amplifier. I can see it's voltage divider biasing. It's a common emitter amplifier, and I can see that swamping has been applied. Do you agree? So what do I have to do with a with a multi-stage amplifier? I have to go, what's the purpose of a multi-stage amplifier? I want to increase voltage gain. I have to determine voltage gain of the first stage. I have to determine voltage gain of the second stage. Is that true? And you have to tell me what you work with. Tell me, this is stage 1, this is VB1, this is VE1, this is R accent E1. So that I know what you're doing. Alright, so what's the first thing that I do? To recalculate what? Yes, by doing what? I have to check if the circuit's stiff or not. By what? By doing what? R in at the base. No. I have to go and calculate R in at the base. Let's go and have a look at the solution here. R in at the base 1. Beta DC 1. R4 plus R5. There were 2 different beta DCs. I don't know if you've noticed. I've given them both. For both transistors, there they are. Beta AC is equal to beta DC is 100 for that transistor. Beta AC is equal to beta DC is 5 for that transistor. Work with the first stage now. Okay, I go and calculate it. Multiply R2 with 10. And I see that 94 kilo ohms is not larger than 220 kilo ohms, so it's not stiff. So you got 1 mark there for calculating if it's stiff or not. And then you had to use the correct formula, of course. If you didn't use the correct formula, wrong, and you didn't get any marks. So the answer there, 1,816 volts. That answer there is if you used the wrong formula, which at this stage you still didn't get any mark. Okay? Then I had to go and calculate IE. IE, of course, is VE1, which is VB1 minus 0,7. 1,116 volts divided by, I don't know, some of you only used one resistor here. I'm busy with the DC part. So that capacitor don't count, does it? So I have to include both resistors for the current. Current flows through both the resistors. I'm calculating DC. It's V, E, and IE, capital letter subscripts, DC quantities. There, milliamperes. From here, if you calculate it correctly, I started giving you marks if you used the wrong formula. If you calculate it correctly. That's what that second set of answers there are for. Alright, once I've got IE, then of course I can calculate R accent E1 because I need it to do my AC calculations. 25 millivolt divided by IE. I'm calculating R accent E1. You have to tell me what you are calculating. 21,062 ohms. I don't know if you've realized, but I wrote the question number here. Ne? Can you see basic problem 633, which I modified a bit. Ne? Alright, back to the answers. Now I can also calculate VC1. Why do I have to calculate VC1? What is this? Is it capacitively coupled, multi-stage, or a direct coupled? Direct coupled, of course. I can see here that VC1 is equal to VB2. You have to tell me that. You can't just say VC is equal to VB. Not true. No? Not true. Alright, so VC1, of course, the current that I've calculated, IE, which is equal to IC, I multiply with R3, which is RC, so I'm calculating the volt drop over RC, and I subtract it from the supply voltage. 9,389 volts, and then VB2 will be equal to that value. Then you got another mark. All right. Please have a look how the marks are allocated. Don't come and see me, sir, but you didn't give me a mark here. Have a look where I give the marks. It's not for you to decide where you should get a mark, ne? Alright, now, that mark was actually there. Then I can calculate IE2, isn't it? But you have to say what you're calculating, which is now VE2 divided by the total resistance again, R7 plus R8. And I get a current now of 924,361 microamps, not 0,924 milliamps. For another mark. Then I can calculate R accent E2. You have to tell me. You have to tell me what you are calculating. I cannot smell it. And in this case, 27,046 ohms. Alright, now I've calculated the first stage and the second stage DC parts, and I've calculated the R accent E's. Because I said in the question, do not neglect the internal AC resistance in your calculations. Ne? Okay, so I've calculated the DC parts so that I can get both IEs, so that I can calculate both R accent E's for both stages. Alright, now, if we go back to this figure, we have established that this is a direct coupled multi-stage amplifier, né? Okay. We have established that. Now, what do I know when I calculate voltage gain? Voltage gain is equal to RC over Rx and E. Now I have to go and look. Rx and E, for instance, we're going to calculate AV1. So I'm going to use Rx and E1 because I said not to neglect. Is that all that I have to include? No, I have to include R4 as well because only R5 is bypassed. Do you agree? Plus R4. That's below the line. Now, on top of the line, RC. And this is which I stretched while we discussed these multi-stage amplifiers. That's the only thing that you have to remember, how it differs from a single-stage common emitter amplifier. We know for a single-stage common emitter amplifier, if there's a load resistor, I have to calculate R lowercase c, which is RC in parallel with RL, isn't it? What do I have here? A second stage. What do I do firstly when I calculate a common emitter amplifier? Input resistance, because I also have to calculate AV2, isn't it? And I've seen it's direct coupled, not like some students calculated. They still said for the second stage it's R1. No, some of them used R3 and 4. R3 in parallel with R4 in parallel with the rest. There's no voltage divider. VC1 is equal to VB1. I already have the base voltage. What I do have to calculate is the input resistance. How do I calculate total input resistance for a direct coupled multi-stage amplifier's second stage? There's no voltage divider. I stress it again. So I cannot calculate like for the first stage R1 in parallel with R2 in parallel with R in at the base. There is no voltage divider, so it's only going to be R in at the base. What is R in at the base for the circuit? Note the different betas. Let's go to the solution. R in 2. Beta AC times Rx in 2 plus R7. I said not to neglect Rx and E. That is beta AC2, ne? You can see there, 125 times Rx and E2 plus R7. I get an answer of 590.881 kilo ohms for another mark. Now I've got everything that I need. Voltage gain of the first stage. What is voltage gain? RC over Rx and E. I have to go and look at the circuit. Is there a load resistor? No, but there's a second stage, so I have to use RC, which is R3, for my first stage in parallel with R in of the second stage, which is 2.2 kilo ohms in parallel with the 590.881 kilo ohms. That gives me an answer of 2.192 kilo ohms. Below the line, swamping has been used, and I said do not neglect Rx and E. So I have to include Rx and E1. Only R5 is bypassed. I have to include R4. If I add the two together, 491.062, and I get an answer of 4.464 for another mark. That's the voltage gain of the first stage. Voltage gain of the second stage. Do the same thing. RC over Rx and E. Is there a load resistor? Yes, there is a load resistor. So RC is in parallel with RL. RC for the second stage is R6. In parallel with RL, 10 kilo ohms in parallel with 4,7 gives me 8,246 kilo ohms. Below the line. Told you not to neglect R accent E. So that's why I calculated it. And I only bypass R8. So I have to include R7. 27,046 plus 4,7 kilo ohms. I hope you noticed that these two stages aren't identical as the other example that we've done. And I get an answer of 1,744 for another mark. Now I've got the voltage gains of both stages. Get the overall voltage gain, it is the voltage gain of the first stage multiplied with the voltage gain of the second stage. I get an answer of 7,785. And if you've done it correctly, you got 11 marks as indicated. Don't come and tell me, sir, but I've calculated this. Isn't it worth a mark? Only as allocated. Alright? And if you've done all the other things that we talked about, not using engineering notation and accurate calculations and so forth, I don't want to hear stories. Alright, everybody happy with that multi-stage amplifier? Okay, then I took it a bit further. I took that same circuit that you just calculated. I made life very difficult for myself. I had to do so much marking through of mistakes. But anyway, 2.4. I said, if the multi-stage amplifier in figure 2 is now driven by a 75 ohm 50 microvolt source, determine the overall voltage gain. Not the output voltage like some of you did. The voltage gain. What do I know as soon as I have this? What is this? RS, né? Internal source resistance. Then I know I have to calculate attenuation. But to be able to calculate attenuation, what do I need? We didn't calculate that yet. It wasn't necessary. First stage. R1 parallel with R2 in parallel with the input resistance, which is beta AC of the first stage times R accent E of the first stage plus R4. And you should get an answer of 13,189 kilo ohms. Then you got 2 marks. The next thing, if you calculated the attenuation, some of you still insist on using that formula in the textbook, which I don't understand, but I marked it anyway. Man, I hate this thing. The attenuation, I told you, it's a normal series circuit, voltage divider, because of RS and the total input resistance. It's a ratio, always correspond to a value of less than 1. In this case, 0,994. And then all that I had to do is take my voltage gain from my first stage and my second stage that I calculated, and I multiplied it with 0,994. And then, of course, it becomes less than it was because of the attenuation. 7,739. 4 marks all in all. Now, some students are going to tell me, but sir, it was unfair to ask the multi-stage amplifier. You told us 6.8 is so important, which is the common emitter amplifier. Of course it was important. It was so important I asked it twice. First stage and second stage. Only difference is load resistance for the first stage is the input resistance of the second stage. Anyway, oh, my personal favorite. Number 2. My personal favorite number 2. Question number 3. The differential amplifier. Question number 3.1. The DC base voltages in figure 3 are 0. This question, by the way, is exactly as in your textbooks, basic problem 6, number 36, which just goes to prove that you didn't do the homework. Oh, so by the way, I didn't forget about your homework books. I'm not interested in seeing them anymore after marking this first test. So you can keep it. I never want to see it. I never want to see it. All right. So what do? Multi-stage amplifier. There was an excellent lesson that's on video also on this. So, VE, what is VE? It's the supply voltage minus VE minus the VE, which is minus 0.7, so I should get minus 19.3 volts at this stage. Ne? Then I can calculate the current through RE, because I've got the voltage. So it's VRE over RE, gives you 8.773 milliamperes. If you wrote that, you got a mark. Then, of course, the current splits, isn't it? IE1, IE2. Two circuits the same, so it's IRE divided by 2. And this is where the rounding off comes in. If I divide 8.773 by 2, what do you get? You get 4.3865 milliamperes. How do you round it off? All the students tell me, no sir, this becomes 4.386. Where did you go to school? How do you pass mathematics? So you most probably lost a mark there. I think I gave the mark here, but right in the end where you showed me what is your differential voltage, you were 1 millivolt out and you didn't get the mark. Because of this. Remember, I said calculate accurately. Then, if you noticed, as you should have noticed in the homework, that was a very important clue. Alpha was given for both transistors. So you cannot tell me IE1 is equal to I, because it's not true. I've given you these values. So you have to calculate IC for each transistor, because alpha is the ratio between IC and IE. You've just calculated IE. I've given you alpha, so you can calculate IC. So for the first one, 0.985 times 4.38 milliamperes gives me 4.321 milliamperes. And the next one is 4.255 milliamperes, 1 mark each. And then you can work out the differential voltage by calculating VC. Some of you calculated VRC, which is not wrong. You can calculate VRC, but then you shouldn't call it VC. VC is VCC minus the volt drop. You cannot tell me VC is equal to ICRC. That is not true. And then, of course, the differential voltage I subtracted 2, I get an answer of 217 millivolts. 7 marks all in all. If you didn't calculate correctly, you most probably lost your mark here. Also by telling me it's 0.217 volts or something like that. You also didn't get the mark. So make sure about that. And then lastly, I don't know why I did it, just to ask you something from this chapter. which was shocking, more than 3/4 didn't know how to measure the bandwidth. I got the strange and weirdest answers here. To indicate, not calculate, indicate on the figure how you would calculate bandwidth. So it was 37 marks all in all, so I gave you 2 marks. And you won't believe it, between me and Mr. Fourie, we've got 2 students. I've got 1 student that I've marked 36 out of 35, and Mr. Fourie got 37 out of 35. Was not a difficult test. I asked you your homework. All right. Anyway, if you are unhappy, you can come and see me. Even if you aren't unhappy, you still come and see me because you have to sign. I will be standing over there. All right, this concludes this test. Test number 2 will be written shortly.